So hello guys, today we are going to first of all welcome to my first ever video, and today we are going to see the first algorithm of the machine learning. So I'm not gonna teach you here. I'm not a teacher. I'm just a student like you, and I'm trying to and I'm learning all the algorithms and the of deep machine learning and deep learning, and I'm going to explain whatever I have learned here. So today's agenda is we are going to learn about the linear regression. Yeah, so there are three types of the regression. First of all, one is the linear regression, second is the multiple linear regression, and the third is the polynomial linear regression. First is simple linear regression. Today we are going to see the simple linear regression, and afterwards uh, the simple linear regression contains two variables. Multiple linear contains multiple variables, and the polynomial regression contains, I think, mm, polynomial regression creates a polynomial feature according to degree, and it will help you to curve your linear regression. So forgot rest of the things, and let's focus on the simple linear regression. So we will start with the introduction first, and after the introduction we will go with the mathematical intuition behind the simple linear regression, how the intercept and the coefficients are calculated, how the formulas of those derived from the derivations, and all of the things we have to see here. And after that we are going to make our own algorithm. We are going to make a simple linear regression, but in our way. We are not using the scikit-learn algorithm. We are going to create our one. Okay, so let's start with the introduction first. So what is the linear regression? Linear regression is a simple linear regression, not a linear regression. Let's focus on the simple linear regression. So what is simple linear regression? It is nothing but one of the supervised machine learning technique used to model a relationship between and two variables, or the features we can call it in our data science. So first feature is the independent variables, and the second feature is the dependent variable. Independent variable is also called as the input variable, and the dependent variable is also called as a target variable, which we have to predict. Yeah, why? So in simple linear regression there is only one independent variable. According to that, we have to predict the dependent variable. There must be a linear relationship between these two variables. In linear regression, independent variables must be more than two. Okay, and so yeah, here is the definition of linear regression. Is a supervised machine learning technique used to model the relationship between an independent variable, that is x, and the dependent variable, that is y, by fitting a straight line through the data. It answers the questions: if I know x, what value of y I expect. So if you focus on this, let me yeah. If you focus on this diagram, you can see here is the uh, linear the sort of linear relationship between the our studies and the exam score. So our studies is our x variable, uh, or the input variable. If you give input of the our studies, so our model should predict the exam scores. Okay, so you can see how the hours studied increases, exam score also increases. So we can say here the positive or the linear regression linear relationship is there. And yeah, so what simple linear regression does? So it will create a one line. also called as a best fit line, and it should go through the all the data point, not all the data points. It should go from the data points which covers mm, which should contain minimum error. Okay, what is error here? So let's start with the simple linear equation. So this is the y is equal to mx plus b. This is our very famous linear regression formula or the equation. Everyone use this, and scikit-learn's default mm, mm, what function also use this formula. And so y is what? Y is the predicted value, exam score, and the x is the input value which we have to provide. M is nothing but the slope, how steeply y changes as x changes. Let's discuss it afterwards. And b is also the intercept, the value of y when x is equal to 0. Okay, so yeah, after creating our model or the training our model, we will get this best fit line. What is, yeah, best fit line? This is the equation of the best fit line. What is y is equal to 3.78x plus 6.3, whatever it is. Yeah, so you can see here it goes from it it never goes from all the data points. It is not possible, and if it goes from all the data points, then overfitting should be there, and this is the biggest red flag for our model. uh, you can see here how line goes from the some data points, minimizing the errors of the all other data points. Okay, so what is b here? M here, what is m here? So you can see here how steeply y changes as the x changes. Okay, so if the x changes from the one data point to another data point, it shows how y changes. Okay, so let's see. Yeah, here is the so let's see in detail what is the slope and the intercept, also known as the m and the f. These are the most important things in the simple linear regression or the multiple linear regression. Why? These two value gives you your best fit line. Okay, the whole model is dependent on these two value. If the m changes, the line changes. If the b changes, the line changes. Let's see how the line changes if the m changes. Let's see the definition of the slope. The slope tells you how much the y increases for every 1 unit increase in x. A larger slope means a steeper line. The y changes quickly as x changes. A slope of 0 would mean a flat horizontal line. X has no effect on the y. Let's suppose there is one data point and another data point is here. So if we see this much, we can say that this much change in the x is happened here, and how much change is there in the y. So we can say this much, this block, yeah, you can see here is this block, this much change happened in the y. So nothing but this is our slope. Yeah, from this point to this point, that much x changes, and according to this much y changes. I don't have any pencil, and as this is my first video, I don't know how to do this. So can we see what is this? Yeah, we have the pencil here. Let me show you. Yeah, let's take another color, black. Okay, so this is our first data point. Yeah, and this is our second x values. we can say here this much change, we can say that this much change is there in the x in two data points. So how much y changes? So how would know how we can know how much y changes? So we can say this much change is happened in our y value. Yeah. So the value of this is called as a slope. Okay. I think you have got this. This is this much change happened in our y variable. Yeah, y changes quick. The sort of tells how much y increases. Y increases from 5 to 10. So we can say here our m value is 5. Yeah, we got our m value here. So how do we erase this? Yeah, let me erase this. Yeah, I suppose that you have got what is the slope, and let's see how the line changes according to m, according to change in m. Okay, so when the m is 0.5, the line is this. When the m is 1.5, the line becomes this, and when line m goes to 3, the line becomes very steep. Okay, so how the m increases, the line goes more steeper and steeper. Okay, the line with the same starting point but the different slopes. Notice how larger m makes the line lies more sharply. Yeah, so this is all about m, also known as a slope, also known as a coefficient, also known as a bias. Okay, there are many names, many more names of the intercept here. So let's go towards the effect of intercept. Yeah, intercept yani b. The intercept is the where the line crosses the y-axis. That is the predicted value of y-axis when x is equal to 0. Changing b shifts the entire line up or down without changing its steepness. Okay, so y is nothing but what is it? Intercept is nothing but the starting point of a line which on the y-axis. Okay, so I can say we can see when the b, that is the intercept, is the uh, let me draw something here. Okay, let's suppose this is our x-axis and this is our y-axis. This is our 0 and this is our 1, this is our 2. Okay, so this is, we are plotting the graph here, and what is intercept here? So if our line, focus here, if our line goes from the 1, okay, this is our base fit line, suppose, and this is our some point. Yeah, so what is the intercept? What is the intercept here? We can see here the 1 is the our intercept. Okay, this is simple. We have to calculate this b. We will see how the formula of b is, what is the formula of b and all. Yeah, so I think we have got this, what is the b and how the line changes if the b changes. We can, if our b is 2, then our line towards upwards moves upwards, and if our line b becomes 0 0.5, let's say 0.5, then our line goes from this. Yeah, how the b changes, line changes. You can see here the graph. Let's see what is the residual. Yeah, residual also called as a residual also called as a error. So is nothing but the difference between the actual actual y values and the predicted y values, also known as a y hat. We have to calculate the difference, how much our mainly this helps to calculate how much our what do we say, model is giving the error or the misleading us. Okay, if let's see the example here first. No line passes through the every point perfectly. The gap between and the actual observed values and the value that line predicts is called a residual, okay, or a error. We can see here our studies and the exam scores. Let's ignore this. Let me tell you in our own data point. Okay, let's see. Let's suppose I have studied every day. I have studied for the 20 hours. Okay, so and let my input is 20. Let's suppose I have studied for 20 hours and we will get prediction. Our predicted values becomes this, near about 28 to not 80, near about 80. Okay, so our predicted value is near about 80, but I scored more than 80, and let's suppose I have scored 100. Yeah, 100. So error is nothing but the difference between this mistake or a gap we have here in our predicted value and the actual value. So our actual value is 80. Our actual value is 100, but it's predicted as a 80. So this is our error. Yeah, it's simply fine, and I have explained it simply. You can see here that each gray vertical segment is a one residual or the one error. The distance between the real data points and where the line predicts it should be a good fit keeps this distance small overall. Okay, so while the creating or the training model, we have to keep in mind, we have to minimize these mistakes or the gaps between the actual values and the predicted values. Okay, so this is our aim in the whole linear regression. We have to minimize this all the gaps, and we have to fill these gaps. Okay, so let's go ahead. This is our error. While creating model, we never take simply a sum of all the errors. We take the square of the sum of all the errors. Why? Let me see in the next. This is the gradient descent and all. We are not gonna see here the gradient descent. So what is the gradient descent? Let me tell you in a brief. So gradient descent is nothing but the probability based models or algorithm we use the SDE regressor to apply the gradient descent on our linear regression. Gradient descent is nothing but the model which helps to try to minima and calculate the all the y predict values from this, and which technique we are going to see is known as the OLS. Okay, what OLS, also known as a ordinary least square method. The sklearn's linear regression module uses this method, and if we have to use the gradient descent, we have to use this model. Okay, why? Let me see the difference. Not a difference. Then let me clarify you that why we use the gradient descent if we have the formula based OLS method. So sometime in the multiple linear regression, when we do the multiplication of the inverse matrix, so it takes a lot of calculations over there. I think n power to 3 calculations become n power 3 calculations are there becomes for the one values, and if our data contains 1000 values, then the calculation number becomes 1000 power to 3, which takes a lot of time and energy. So that's why we use the gradient descent there. So let's ignore this for a while. Assumptions and this evaluation matrix we are going to see in the next video. Let me take you to the 22 minutes video, 22 minutes of videos becomes here. Let me take you to the the derivation of all the formulas of the B and C. So as we know, our our best fit line formula is y is equal to mx square. This is the formula will calculate the best fit line, but we don't know what is the m and the b here, and these are the main values we want to calculate the best fit line, and our goal is to find the value of m and b that makes the prediction error as small as possible. Okay, so what we have to predict here for the every x values, also known as xi, either it is x1, x2, x3, x4, whatever it is, for the input xi, model should predict the yi hat, also the prediction of the x1, nothing but. So xi is the input, yi is the actual output, and the y hat is the prediction output. Keep these notations in your mind, which will help you afterwards. Okay, so suppose we assume the m value is equal to 2 and the b value is equal to 1. Yeah, and no need to suppose here. There is no calculations afterwards. Okay, so let's find the error. What is the error? Error is yi minus yi hat. Error is also known as a residual, as we have seen in our PDF. Okay, we know yi hat is equal to mxi plus b, as we have mentioned here. This is the main formula of our prediction. So let's take example that our actual value is 8 but our model predicts 7. Then what will be the error? 8 minus 7 is equal to 1. So here is the square the errors. Negative and positive errors cancel. Okay, so let me tell you why we take the square of errors. Yeah, so this is our squared error function. Did you get why we take the x mxi plus b? Because uh, error function is this and y I hat is equal to mx plus b. We have put this here. Okay, this is simple. Let me show you why we take squares of the errors. Let's take where is let's erase this. Yeah, so why would take the square error? Let's suppose first error we get as a 2, second error we get minus 3. Then what will be the sum of errors? 2 plus minus 3. So it will become minus 1. Yeah. So all the errors are cancelling out. If the errors, if model predicts the less than the actual value, then minus values comes here and it will cancel out the positive errors and it will become minus 1. And what if we take the squares of errors? It will become 4 plus 9, which is also 13. Okay, so to cancel out the minus, we take the what we take the squares error. Nothing special is there. As the data has many input, we add every squared errors and the formula becomes this, and this is also known as the cost function or the loss function. More preferred name is the loss function. So in this function we know all the things but we don't know the m and the b itself. Okay, so we have to find the minimum and at the lowest point where our derivation starts. So what we have to derive here, we have to derive the loss function, that is also the j in respect to m, and also we have to derive the j in respect to b. The partial derivation we have we are going to apply here. And why we take is equal to 0? Because the lowest point of the derivation is 0, as we know, and we have put it the zeros here. So let's keep in mind j is our loss function, and let's derive each. What first we are going to derive the j in respect to m, and afterwards we are going to see j in respect to b. Okay, the slope of curve is exactly 0. Let me see if the video is still on or not. Yeah, this is my first video and I don't know how much long it will keep on. Yeah, so let's first differentiate with the respect of b. Start with the, yeah, let's take our loss function as it is, and as we take this function, what equation, we can see here there are two functions. We can see this is the inner function and this is the square outer function. What is the inner function here? Inner function is yi minus mxi plus b, also known as the u. And the what is the outer function here? x square is the outer function here. So when we have outer function and the inner function, as we know, we have to apply the chain rule here. Okay, so our derivation becomes u square. uh, Now we have the u square here. So we are not currently we don't we are not going to focus on the inner function. Let's focus on the outer function, which is the x square. So as per the power rule, for the x square we have to apply power rule. Okay, uh, let me tell you in brief what is the power rule. If the we have to take power in the multiplication of the variable, and the um, minus we have to minus 1 from the power. Okay, so if the variable is x square, then according to power rule it will become 2x. we have You have to know all the derivations, how to derive. You have to you have to what yeah you have to learn all the calculus, how to derive, how to differentiate the equations. Okay, then only we will know all these steps which I have doing here. Okay, so according to the power rule we have taken the 2u here, and now we have to perform the multiplication of the inner what inner what inner function. Okay, yeah, we have taken the 2u plus de yeah we have to differentiate the u now. Yeah, let me tell you clearly here. We have taken the power of this power of u square here, and now we have to multiply it the differentiation of u. Yeah, u, this is the inner what is u, this is inner function. We have to differentiate u in respect of b. Okay, first what we have done here, we have differentiated the j in respect of b. Now we have to differentiate the u in respect of b. So here u is equal to yi mxi plus b. In partial differentiation, we differentiate in respect of that values which we have to differentiate. Okay, if let me tell you, if the now if let's do it now. Okay, so what is the first value here? This is the yi. So it does not contain a b here, but we have to differentiate with respect of b. So yi becomes constant because it does not contains b. So as the constant rule, constant value derivation of constant value becomes 0. That's why we have taken the 0 here. And what is the second value here? mxi, you can see here. It also does not contain the b here, that's why its derivation becomes 0. And the third value is b. B itself is a b, and if there is nothing, and that's why we take 1 here. We derive the b, we differentiate the b here. Okay, so yeah, our b is minus b because there is a minus in, so this is wrong here. There should be a minus 1. Okay, this is minus 1, suppose this is minus 1. Yeah, so what is the du differentiation of u in respect of b becomes is the minus 1. So we have to put that minus 1 into this formula, yeah, as we have done here. and we have to write the u as it is. What is u? You can see here u is yi minus mxi plus b. We have to write this u after the 2. Yeah, so our equation becomes this. Got it? Our equation becomes this, and 2 into minus 1, it becomes minus 2. This is our equation. Let's take it to the minimum at 0. And what we have done here, we have next divided the whole equation by the minus 2, which cancel out this minus 2 from the equations. Now we have to expand this equation, or the summation of the equation. We have taken summation of yi separately, we have taken summation of mxi separately, and we have also taken the summation of b separately. So what is the b? As we have said here, b is nothing but the intercept. Okay, b is nothing but the intercept. Can we say that the intercept will be the same for every data points while calculating the y hat? Yeah, we can say, because our line is simply a single line here. So our b should be and must be the only one value. Yeah, it it can't differentiate from the value to value. Okay, yeah, slope is differentiate because we have to calculate the change in y according to change in x, but b will not change. Okay, b remains the same for all the data points we have to calculate. Yeah, so since the b is the same for every data point, adding it for n times gives the, yeah. So what here is, what is done here, our b is 1. Okay, so what is summation of b for every data type? If our uh, if our data contains the three records, and then suppose there are 3 records in the data and our b value is 2, then what is the summation of b? 2 plus 2 plus 2, it will become 6. But what if we do b into n? It is simply the intercept value, which is 2, into the total number of records. It also becomes 6. So why not we simply take the bn instead of the summation of b? Okay, so we have taken the nb. What is the bn nb for the summation of, and we have rewritten the equation here. Yeah, here we have taken the b b in the right hand side. No, we have taken this whole equation to the left hand side, and this nb becomes in positive. Finally we will divide it by the n. Yeah, we divide it by the n, and this n this n cancel out. Yeah, let's see. As we know, what is the x bar here? X bar is the summation of x divided by number of records. So we can say this summation of x divided by n becomes x bar, and as the y bar is the summation of y divided by n. So we can write this formula into this. So this is our final formula of intercept, y bar minus mx bar. Yeah, Now we have got the intercept formula here. Let's move ahead. And let's find the m now. Okay, m. We have taken the loss function as it is here, and what we have done here, instead of y hat I, we have taken the no. Yeah. So this is our loss function. This was our loss function, and we have taken as it is here. Now we know the value of b. So as we have uh, find it derived there, that is the y bar minus mx bar. So now we know the b. So we are simply going to put y bar plus mxi bar into this b. So our equation, our error becomes this. Now let's differentiate it with the respect of m. Okay, so here also we are going to apply the chain rule. This is our u, which is the inner function, and this is our outer function, eu square. Okay, so we have taken the 2u power of the u square and into differentiation of u in respect of b. First we have differentiate in the respect of differentiate the j, which is the loss function in the respect of m. Here we are going to differentiate the u in respect of m. Okay, so our differentiation becomes this. This is our 2, this is our u. Yeah, this is our 2 here, and this is our u here, and this is our differentiation. We have to differentiate it now. Okay, here is the differentiation. We have to differentiate here in respect of m. Okay, so yi is the constant, it does not contain the m, that's why it becomes 0. Yeah, as we have written here, and it will become the -1. Okay, it will become -1. It will become what? It will become, yeah, here is the m value, that why it will become -1, and it is for the y bar, it will become constant and 0, and it will become +1. Okay, so we take the 0 for here, we take the minus x bar xi from this, and -0 from y bar. Instead of taking the 1, we have taken the x as it is for the equation, and it will become minus xi plus x bar. So we have added this into this uh, equations. Yeah, let's see here. So here what is done for the minus xi plus x bar, the -1 is taken outside the bracket, and -1, it becomes -1 x minus x bar. Okay, minus symbol is taken into out of the bracket, and now it will multiply with the 2, and it becomes the -2, and u as it is, and it will become xi minus x is equal to 0. Now we are going to divide the whole equation with the 2, and 2 will cancel out, -2 will cancel out. Now what we are going to do is taking the inner function or the u, and we have we are going to rearrange it. Okay, so we are taking the yi minus y bar in the one bracket and minus m in the, we are taking this minus m and this m commonly in the out of the bracket, and this xi minus this x bar in the bracket. Okay, and this as it is. Okay, so after that it will become yi y bar, and then this xi will come here, xi minus x bar and minus m xi x bar square. Okay, y xi x bar square, it will multiply with this and it will become square. Okay, so we have taken this m xi x bar square out at the right hand side, and then it will become positive. Then what we are going to do here, we are going to take this from here to here, and it will comes into division. Here it is in multiplication, it will come into division, and we will get here our m values. Okay, so this is our m value here. We have, yeah, here we have our m b. Now we can calculate our y pred. Okay, so let's do this in our code. Let me take you into the code. Let me show you how the linear regression model will help you to calculate this. We have taken here the sample data of the placement.csv. This data is the created by own. Randomly I have taken the some values and make it the sort of linear, and we have train tested split with the sklearn dot model selection. We have taken the xtrain y train x test y test here. We have taken this linear regression from the sklearn dot linear model, and we have the lr dot fit xtrain comma y train. This is our whole x train, this is our whole y train, and this is our lr dot predict. We have predicted here the first value which is the 3.89, and we have plotted the best fit line here, and these are we have taken the coefficient and the BLR intercept here. Let's create our own linear regression algorithm here. Okay, we are going to use the numpy and pandas here. So how we can create our class here? So let's create our class my LR. This is our class. We have to define the constructor here. Let's define the constructor over here. Self dot m is equal to none, comma, not a comma, self dot what b, also intercept. You will become none here. For now it is none. Now we are going to define the two function over here. First one is fit function, which will help to fit our algorithm to the model. And what we are going to take here, let me turn of the agent here. Inline suggestions, smooth for the 30-40 minute. Yeah. So what will come here? Here first, let's take the self extra extrain comma y train. So first we are going to calculate the self dot m here, which is also the coefficient of our model. So as we know the function, where is the function? Yeah. First we have to calculate the numerator, then denominator. Okay. So let's call the numerator here first. Numerator is equal to 0, then denominator is equal to 0, and for I in the range x train dot shape uh, 0, number of rows. We are here we are iterating the one for loop for the number of x train. Why I have taken the here? For I in range x train dot shape. Yeah, we have taken the number of rows from the x train. It will, what it will do? Why it's showing the error? So what it will do? It will iterate the iterate over the x train shape, and y will become the number of the row. Okay, so nothing but this is the number of the row. So what we are going to calculate here? First we are going to calculate here the num, which is the numerator, is the simply the summation of the e xi minus x bar into yi minus y bar. Okay, so this is the num plus, let's take the first bracket, which is the xi minus x bar. There is the xi is nothing but the x train dot I. Let's take the index directly. X train I. The first, it will take the first value of the x train, and x train 1 minus x bar. Let's take the x bar here. X, which is nothing but the x train dot main let's, what is the next? Y minus y bar. Okay, so let multiply this with the y train yi minus y train dot mean. This is the numerator xi minus x bar and yi minus y bar. Okay, what the numerator equation here. Let's calculate the denominator here. What is the formula of denominator is summation of xi minus x bar square. Okay, square of summation of xi minus x bar. So here what we are going to do here, summation of xi minus x bar. Let's take this summation of xi minus x bar we have already calculated here, and we have to take the square here, and let's multiply this with it itself. Then it will become the square of the xi minus x bar. Yeah. So uh, so this is our m. What the hell is happening here? What is the fault here? Yeah. We have taken the double bracket here. No need of the double bracket. And now let's initialize the self dot m here, which is nothing but the numerator divided by denominator. Hmm. Yeah, divided by numerator divided by denominator. And let's take the self dot b. What is the formula of b here? X main, x bar, y bar. Let's take the y train dot main, minus self dot self dot m self dot m into x bar. Where is the into x, capital X, train dot mean. Let's combine this into the, so this is our intercept formula, and now we are going to print the values. Let's take this outside the loop. Oh my god. Let's take this outside the loop. Let's print out the self dot m and the self dot p. Now let's predict the let's create the predict function over here, where we have to take the self comma x test. So what is the prediction formula here? As we know the y is equal to mx plus b. So this is our formula for the prediction, and let's predict this. Let me give a minute. Let me take a minute. So we are back. Let's where is our code? Let's what is the return y hat is equal to m plus what is our formula? Y is equal to mx plus b. Okay, so let's take the self dot m into mx x test plus mx plus b. Self dot b. So this will be our predict function. Let's test this function over here. Let's test this, and first we are going to split our data into the 80-20. For the let's copy this cell here, control C, and let's test the it will taking some time. We don't have the x and y here. Let's calculate the x and y first. Control C, Control V. Why it's taking the time? It's become the 1.4 hour long video. Let it run first. It's been definitely this class will be work. Let's see if it connect with the kernel or not. Too much time it's taking. Let's see what happens. So currently my laptop is not working well. I have to see what happened to this. So you can take the screenshot of this code over here. This will work to calculate your intercepts and b value, and according to that it will uh, give you the correct predictions. Like a scalar linear regression function, we have created this our own function or the class here. Using this you can create a model which will give the as it is output like the sklearn's model. There will be a nothing change in the output given by this and sklearn model. So you can refer this, take a screenshot of this code and use it in your own system and try to find out the x values, find out predict the y values according to x. Yeah, so yeah, like this you can predict the y value over here. It will give the as it is. Let me see if it works. Why it's behaving like this? So you can try this on your system and it will accurately give the um, correct prediction. I must tell that. Yeah, so this is for a day, and remaining assumptions and the evaluation matrix we are going to see in the next, or the after the multiple linear regression we are going to see that in third or fourth video. For till you can try this code over in your laptop, try to create your own datasets or take it from the Kaggle, a random linear regression dataset. You can create, take a data and you can create this all the functions. So simply this is for a day, and if I have done anything wrongly or if I have done any mistake, let me know in the comment and let me learn from the mistakes also. As I am a student like you, I want to learn more and become a better in the machine learning. So So yeah, this is for a day. Let's meet in the another video. Till stay tuned, and if you like the video, subscribe the channel and hit the like button. Okay, bye.